Sai Ram. Om Sri Sai Ram. Today we are beginning a new topic called three-dimension geometry. Very interestingly, it is the combination of the coordinate geometry which you have studied last year in 2-dimension and the vectors which you have done just before this session. The combination of both you will find in 3-dimension geometry. Basically, everything which we see around are 3-dimensional in shape and size. The room in which you are living, the book which you are holding, the table which you are using, all of them are 3-dimensional. But in order to understand the concept of 3-dimensional geometry, we have studied 2-dimensional geometry, and in 2-dimensional geometry we have a plane. Now for example, table is a 3-dimensional object, but the table top is 2-dimensional. It has got length and width. Paper, it has got length and width. No doubt it has got a thickness, but it is very less. But you cannot say there is no thickness, because when you put 100 papers together, you say it is a notebook. Now, what is that we basically need to understand in 3-dimension geometry? Like 2-dimension geometry, in coordinate geometry, you have studied about lines and various types of equations of lines. Starting with y equal to 0 equation of x axis, x equal to 0 equation of y axis, y equal to mx plus c, x upon a plus y upon b equal to 1, ax plus by equal to c, x cos alpha plus y sin alpha equal to p. Several equations as we studied about line, but remember the line was in plane. Now the line is in space. What do you mean by space? For example, the room in which you are living, if you take one particular corner of the room and assume that that is the origin, and the length of the room if you take it as x axis, width of the room if you take it as y axis, height of the room if you take it as z axis, any object in this room we say it is in space. For example, a tube light which is there or the fan which is hanging from the roof, they are all in the space. So now we are going to study if there is a line in space, what is its equation, how to find its equation, and we are also going to study about planes. So these are the two things under 3-dimension geometry we are going to study. But to begin with, we go back to direction cosines and direction ratios which we have already discussed. But we are going to study the same things with little more detail, few more formulae which can be used. So let us begin with direction cosines. Chapter 10 basically means vectors, okay. Recall that if a directed line passing through origin, there is a directed line means it has got a starting point and its direction is defined, okay. Through the origin makes angle alpha, beta, gamma with x, y and z axis respectively, we call them what? Directed angles. Then cosines of these angles, that is cos alpha, cos beta, cos gamma, are called direction cosines of line. This we have already discussed. In fact, we solved some problems based upon them also. Once again, what are direction cosines? Any vector or any directed line, the angles in positive direction with x, y and z axis, we take them as alpha, beta, gamma. Cosines of those angles are called direction cosines, okay. If we reverse the direction, now instead of going from origin upwards, suppose if you take backwards, then what will happen? These angles will be complementary, okay. So in that case, the angles are going to be supplementary. So the angles are going to be pi minus alpha, pi minus beta, pi minus gamma, okay. If you take in upward direction, in positive direction if you take, the angles are simply alpha, beta, gamma, mostly they are acute angle. Whereas if you take other side, the angles are going to be obtuse angles. Here is the directed line. These are the angles which it is making. One is alpha with x-axis, beta with y-axis, gamma with z-axis. So these are the three angles. Now instead of taking OL, if you take this side, other side if you take, what will happen? What is angle alpha in that case? Remember, this is the x-axis and we are taking this particular line. So the angle is going to be, this one. Similarly with y-axis, it was this. Now if this is going to be there, the angle is going to be, means we have to take this side, so the angle is going to be this side. So in that particular way, the angles directions will keep changing and you will be finding out the other side. You are going to get angles pi minus alpha, pi minus beta, pi minus gamma if it is directed in opposite direction. Know that the given line in space can be extended in two opposite directions, one upward, one downward, has two sets of direction cosines. We have two sets of direction cosines if it is a line. But if you specify that it is starting from origin, then you can have only one set of direction cosines, either upwards or downwards. If you don't define, if it is just a line, then it can have two sets. Given in space, we must take given line as a directed line. These unique direction cosines are denoted by LMN. This LMN are nothing but so to write them in short, we are using LMN. Okay. So generally LMN are used as direction cosines. Yes. If the given line in space does not pass through origin, it is not necessary that the line should pass through origin. Then what shall we do? How to find direction cosines? For example, let us say if it is passing through origin, we are able to measure the angle. If it is not passing through origin, let us say the line is like this. How do you find direction? That is a line, okay, not direction cosine. That is a line. How to find direction cosine for that? Parallel to that, you draw a line through origin. Parallel to this, you draw a line parallel through origin. So whatever this line which is passing through origin makes with x, y, z, it is going to be the same for any line. So that's what he has explained. He says if the given line in space does not pass through origin, then in order to find direction cosines, we draw a line through origin and parallel to the given line. So parallel to that we have drawn a line. Okay. Now take one of the directed lines from the origin and find its direction cosines, as two parallel lines have same set of direction cosines. When do we say two lines are parallel? When their inclinations with x, y, z axis are same. So whatever is the inclination of this line, it is going to be the same for parallel line. Now any three numbers, this is interesting because now we are going to introduce direction ratios. What are direction ratios? Any three scalar quantities which are proportionate to direction cosines are called direction ratios. See the definition. Any three numbers which are proportional to direction cosines of a line are called direction ratios of the line. Generally we take LMN as direction cosines. So we take ABC as direction ratios. So remember they are proportional. Proportional means what? L upon A is equal to M upon B equal to N upon C equal to lambda. A, B, C are proportionate to LMN, means the ratio between L and A, the ratio between M and B, the ratio between N and C is same, which is lambda. So how do you write L? L is equal to lambda A. That's what he has told. A equal to lambda L. Any way you can take, means if you take opposite A by L equal to B by M equal to C by N equal to lambda. So in that case what will happen? A equal to L lambda, B equal to M lambda, C equal to N lambda. Remember, since they are proportionate, either you can take L by A or you can take A by L. The same thing he has explained, L by A, M by B, N by C, he is assuming that ratio to be K. Okay. So, we can say that L is equal to Ka, M equal to Bk, N equal to Ck. Then he squares them and adds. He says L square plus M square plus N square is equal to 1. Why it is 1? We are going to derive it. Till now we have been using it. Just like you have been taught how to use Pythagoras theorem right from 6th standard. But the proof of Pythagoras theorem you study only in 10th standard. Because after learning similar triangles only you can learn Pythagoras theorem proof. Similarly, we have used this formula in solving problems, but why L square plus M square plus N square equal to 1 we will study now. But right now we are assuming that, so substitute the values of L, M, N, you get this K equal to plus or minus 1 upon under root of A square plus B square plus C square. Proceed further in the same derivation, we can say that L is equal to this. Means what? It only means that with the help of this formula, you can convert A, B, C, which are direction ratios, into direction cosines. How? You know A, B, C, divide A with under root of A square plus B square plus C square, that will become L. Similarly, it will become M and the other one will be N. If you divide A, B, C with modulus, you get off direction cosine, where depending upon the desired sign of K, K can be positive, K can be negative. As we told, if it is going upwards it is positive, if it is coming downwards it is negative. For any line, if A, B, C are direction ratios of a line, then Ka, Kb, Kc is also set of direction ratios only. If you multiply A, B, C with 2, with 3, with 4, they are also direction ratios only. Now come to the next, relation between direction cosines of a line. The formula which we have been telling, y L square plus M square plus N square is equal to 1, now we will be able to understand. Now just observe, he says consider a line RS. If you have to find out direction cosines of RS, what do? You, because it is not passing through origin, so what do? We draw a line which is parallel to RS passing through origin. So this is a line which is passing through origin parallel to RS. Okay, now why did we draw it? So that we can measure the angles. And he has taken a point XYZ on this line. What do you mean by that? Go back to two-dimension geometry which you studied. In two-dimension geometry, if you remember, suppose there is a point P, we say its coordinates are XY. There is a point P, its coordinates are XY. What does it mean? It means that if you draw a perpendicular from P, let us say PM is perpendicular, we say this OM is equal to X, MP is equal to Y, as a result the coordinates are XY. Similarly, now observe carefully, from this particular point P, we have drawn a perpendicular, okay, and this X axis is perpendicular to Y axis. In the same manner, when we say there is a point P whose coordinates are x, y, z, how do you reach that particular point? Just imagine, let us say in your room there is a fan. How do you reach that fan from the corner of the room? Corner of the room we are assuming as origin. So what do? From that fan, draw a perpendicular. When you draw perpendicular from the fan, it will fall on the floor, and the floor is two-dimensional. So wherever it falls, we call it foot of the perpendicular. That's what he has tried to show. From P, he has drawn a perpendicular on x-axis. But right now how it appears that the angle is obtuse. It is not obtuse. It is more like this. This is like this. So when you draw perpendicular, automatically it will be 90 degrees. So From the fan, when you draw perpendicular, it will fall on the floor, which will be called foot of the perpendicular. How do we reach foot of the perpendicular? We move x units on x axis, we move parallel to y axis y units, and we reach the foot. What will be the coordinates of the foot? It will be x, comma y, comma 0. From that foot, if you go upwards, you reach the fan, which is the z coordinate. That's what he is trying to explain. He says, from point P, when you draw perpendicular, this is what he is showing. He is trying to show that this angle OAP is not less than 90, but it is 90 degrees. So, OAP is 90 degrees. This is the x coordinate and this is the vector r. This is r. So, just like here, we say this r is what? We say r is equal to xi plus yj in two dimensional. In two dimensional, we say vector r is xi plus yj, whereas in three dimension it will become xi plus yj plus zk. So, OA by OP is equal to x by r. So, x is equal to LR. Similarly, y equal to MR, z equal to NR. Okay. What is r? It is like hypotenuse. Okay. So, x, y, z we have found out, and now substitute. We know that x square plus y square plus z square can be written as r square into L square plus m square plus n square. But we already know that x square plus y square plus z square is equal to r square. So, this is also r square, that is also r square, both will get cancelled. As a result, you will get L square plus m square plus n square equal to 1. This is how the formula is being derived. What is more important is this result. Okay. Now, next one, direction cosines of a line passing through 2 points. Before the previous case, the line was passing through 1 point. Now, we want to find out a line which is passing through 2 points P and Q. There are 2 points P and Q. How to find out direction cosines? We will be knowing the coordinates of P. We will be knowing the coordinates of Q. Suppose one set is x1, y1, z1, another is x2, y2, z2. You can find PQ. We already studied in vectors how to find out position vector of Q minus position vector of P. What will be the position vector of P? It is going to be OP is, let us say, x1i plus y1j plus z1k, whereas for OQ it is going to be x2i plus y2j plus z2k. When this happens, when the coordinates of P are x1, y1, z1, coordinates of Q are x2, y2, z2. When these are the coordinates, we can say that PQ is equal to OQ minus OP, or in other words, x2 minus x1i plus y2 minus y1j plus z2 minus z1k. In terms of vectors, we have already studied this part. Okay. So, he is trying to find out, let LMN be the direction cosines of PQ. How to find direction cosines of PQ? That is what he is explaining. He says cos gamma equal to this, or start with this. What is cos alpha? It is x2 minus x1 by PQ. Cos beta equal to y2 minus y1 by PQ. Cos gamma is z2 minus z1 by PQ. What is that PQ? Is R, modulus of R. As we have seen, under root of x square plus y square plus z square. That is what comes off into denominator. So, put them together, we can say that x2 minus x1 by PQ, y2 minus y1 by PQ, z2 minus z1 by PQ will be the direction cosines of a line joining 2 points P and Q, whose position vectors are x1, y1, z1 and x2, y2, z2. Finally, we come to this formula, which is nothing but distance formula. In 2 dimension you study the distance between 2 points is given by x2 minus x1 whole square plus y2 minus y1 whole square square root. Now since it is 3 dimensional, we also are adding z2 minus z1 whole square. Now a relationship between direction ratios and direction cosines. What is it? The direction ratios of the line segment joining P and Q may be taken as x2 minus x1, y2 minus y1, z2 minus z1. Means he is making our job very simple. How to find direction ratios of PQ? Simply take difference of x, y and z coordinates. You take x2 minus x1 or you take x1 minus x2, doesn't matter at all. That's why he said either you take this or you take this. Both mean same. There is no difference. Now we come to problems which are based upon direction cosines and direction ratios. So let us solve these problems. Let us begin with the first problem. What does he say? If a line makes angles 90, 135, 45, means what? Alpha is equal to 90, beta equal to 135 and gamma is equal to 45. These are the angles with x, y and z axis respectively. Find direction cosines. What is the simple formula for direction cosines? Direction cosines are cos alpha, cos beta and cos gamma. Substitute the values. Cos 90, cos 135 and cos 45. Substitute the values. What is cos 90? 0. What is cos 135? 90 plus 45, which is minus sin 45. So it is minus 1 by root 2. And what is cos 45? 1 by root 2. So these are the direction cosines. L, M, N. Why first one is 0? Because the angle is 90. Cos 90 is 0. So 0 minus 1 by root 2, 1 by root 2 are direction cosines of the given line. Come to the second problem. Find the direction cosines of a line which makes equal angles with the coordinate axis. If it is making equal angles means what? Alpha equal to beta equal to gamma. We have a relation between them. What is the relation? We have studied that L square plus m square plus n square equal to 1. What is L? Cos alpha. So write cos square alpha plus cos square beta plus cos square gamma equal to 1. But in our problem all three are equal. So you can replace them. You can get cos square alpha plus cos square alpha plus cos square alpha. If you add 3 cos square alpha, you will get 3 cos square alpha equal to 1. So cos square alpha equal to 1 by 3. Cos alpha is equal to plus or minus 1 by root 3. If cos alpha is that, cos beta is also same, cos gamma is also same. So he is asking what are the direction cosines. So we can say that the direction cosines are 1 by root 3, 1 by root 3, 1 by root 3. In fact, you can take plus or minus both. Any set, either all plus or all minus. Take the next problem. Show that these points are collinear. How do you show they are collinear? We have proved 3 points collinear by so many methods by now. So many methods. But right now we are trying to do it with the help of direction cosines. How do we do it? Let us say this is A, this is B, this is C. There are 3 points. Okay. We have learned how to find out direction cosines of a line passing through 2 points. So tell me what are the direction cosines of AB? It is x2 minus x1, minus 1 minus 2, then minus 2 minus 3, and then 1 minus 4. All three should be divided by what? Divided by, recollect the formula, distance. How do you find the distance? AB is equal to under root of x2 minus x1 whole square, that is minus 1 minus 2 whole square plus y2 minus y1 square minus 2 minus 3 square plus 1 minus 4 square. Simplify. Minus 3 square is 9, minus 5 square is 25, minus 3 square is 9. 34 plus 9, 43. So here it will come, that is AB similarly this is, what is the formula we have used to find out direction cosines of AB? What is the formula we have used? x2 minus x1, y2 minus y1, z2 minus z1 we have used. We have divided with this. If you wish, you can even avoid dividing with this. You can simply write x2 minus y1, y2 minus y1, z2 minus z1 also. Okay? Come to the last question of the first exercise. He has given the direction cosines of sides of a triangle whose vertices are given. He says find the direction cosines. Once again, like the previous problem, this is A, this is B, this is C. How do you find direction cosines? First find out AB. AB equal to minus 1 minus 1 minus 3 square plus 1 minus 5 square plus 2 plus 4 square. Or even before you solve this particular problem, what you can do is once again just go back, visit what are the formulae and check whether we are using correct formulae or not. Okay? So, we will just do that just to ensure that what we are doing is correct. Yes, you can see this. Direction cosines of a line segment joining two points is x2 minus x1 by PQ, y2 minus y1 by PQ, z2 minus z1 by PQ. This formula we are using it there. Okay? Yes. So, we were saying that this is A, this is B, this is C. So, first find out AB. How to find out AB? x2 minus x1, minus 1 minus 3 square plus 1 minus 5 square plus 2 plus 4 square equal to, simplify, minus 1 minus 3 it will become minus 4, minus 4 square is 16, minus 4 square again is 16, 6 square is 36. Okay? This is AB. In the same manner you have to find out BC, in the same manner you have to find out AC, because he said find the direction cosines of sides. For example, if I only want to write direction cosines of AB, direction cosines of AB, the formula is x2 minus x1 by AB, comma y2 minus y1 by AB, z2 minus z1 by AB. x2 minus x1 What is x2 minus x1? We already did. Minus 1 minus 3. That is x2 minus x1. Minus 1 minus 3 by AB. AB is how much? 68. See whether we can simplify it. So you can write it as 2 root 17. Similarly, y2 minus y1. What is y2? 1 minus 5 by 2 root 17, comma. Finally, we have 2 plus 4 by 2 root 17. Actually, this is the answer, but you have to simplify. How to simplify? Minus 1 minus 3 is minus 4, minus 4 by 2 is minus 2. So, we get minus 2 by root 17, comma. 1 minus 5 is minus 4, 2 ones are 2 twos are. So, again minus 2 by root 17. This is 2 plus 4, 6, 2 ones are 2 threes are. So, you get 3 by root 17. So, these are the direction cosines of what? Direction cosines of one side AB. Same way you can find out for BC and AC by using the same formula. So, what will be changing? You have to find out BC, you have to find out similarly for these 2 points this and get the answer. Okay. From here we are moving on to, this is just an introductory part of 3-dimension geometry, basically to understand two things. What are direction cosines, what are direction ratios and the relation between them, nothing more. This much if you understand, that is good enough. LMN are called direction cosines. What are LMN? Cosines of the angles which a line makes with x, y and z axis. What are direction ratios? Any numbers, any scalars proportionate to direction cosines are called direction ratios. What is the relationship between them? If you know direction ratios, direction cosines can be found. How? L is equal to plus or minus a upon under root of a square plus b square plus c square. Similarly, the other one. Yes, from here we are actually moving to 3-dimension geometry. In 3-dimension geometry, we have two topics. One is about line and another is about plane. As we have studied various equations of lines in 2 dimension, we do not have that many, but we still have 3-4 types. We are beginning with the first type. What is the first type? He says equation of a line through a point. The line is passing through a particular point and parallel to a vector is given by this. This is the formula which we want to derive. So, what we are going to learn is derivation. Okay? So, please pay attention. Let us say this is x axis, y axis, z axis. We have any line. Let us say this is the line. This is a line and let us say it is passing through a point, because he said it is passing through a point A and it is parallel to another vector B. Let us say this is a vector B. And this point's position vector is known. Let us say this is A and its position vector is known. This is A. We want to find out the equation of a line which is passing through a point whose position vector is A and it is parallel to another vector B. Recollect the methods which he used in 2 dimension. Whatever information was given, whether he gave the intercepts with x and y axis, whether he gave point and slope, whatever he has given, for deriving formula, invariably we used to choose one point on the line. Even in 3 dimension, that is the requirement. What is that we need to do? Assume an arbitrary point on the line. Means point can be taken anywhere. Now let us say I am taking a point, we want to find equation of this. This is the line, we want to find the equation. I choose a point here. And when I choose a point, in terms of coordinates, we always call them xy or xyz here. In vector, we call it r, vector r. means its position vector is r. This is r. This is origin. Now come back to know what is known. First thing which we know is OA. How much is OA? It is vector A. What else is known? It is known that line L is parallel to vector B. These are the two things he has given. Equation of a line through a point. What is the point? A, whose position vector is vector A and is parallel to vector B. These two things are given. We want to find out equation of a line. How do we find? This line is parallel to B. Since L is parallel to vector B, any part of the line also will be parallel to B. So AP is a point, AP is a line segment. We can say that AP is parallel to B. Now go back to vectors. When do you say two vectors are parallel? When you are able to express one vector as scalar product of the other vector. So same thing you apply. AP, what is AP? How do you find vector AP? How do you find vector AP? It is position vector of P minus position vector of A. In other terms, we can say R minus A equal to lambda times B. So we found the equation of line. So what is the equation of the line we found? R is equal to A plus lambda B. And this is what he asked us to derive. R is equal to A plus lambda B. Three-dimensional geometry is studied in vector form and also studied in Cartesian form. Earlier people used to study only in Cartesian form, but later on they have clubbed vectors with this and they made it very easy, as we have seen. Suppose if you have to derive the same equation in Cartesian form, we have to assume that the point A has got coordinates x1, y1, z1. This is the first thing. Then you also have to assume direction cosines of vector B. Direction cosines of B. We take them as L, M, N. What else we have to take? We have taken an arbitrary point P. So we have to say that the coordinates of P are x, y, z. Remember, for P we always use x, y, z, not x1, y1, z1, etc. Substitute these things here. Substitute those things here. Means write this in ijk form. So how do you write R? R can be written as xi plus yj plus zk. Why it is so? Because P has got coordinates x, y, z. This we are taking it as x, y, z. This we are taking it as x1, y1, z1. So equal to A, that is x1i plus y1j plus z1k. So R is resolved, A is resolved. Now do it for B. So how do you write it? Plus lambda times, what is B? B is another vector. He has given the direction cosines. So write that also in component form. So how do you write it? Li plus mj plus nk. What is our objective? To get the equation in Cartesian form. How do you do it? By comparing the coefficients of LMN from both sides. For example, in left hand side, what is the coefficients of ijk? Sorry, what are the coefficients of ijk in the left hand side? It is x. If you get this whole thing this side, this whole thing if you bring it to this side, this can be written as x minus x1 into I plus y minus y1 into j plus z minus z1 into k equal to whatever is there, let it be so, lambda into Li plus Mj plus Nk. Remember, left hand side is equal to right hand side. Equate the coefficients of I, j, k. What is the coefficient of I here? It is x minus x1. X minus x1. What is the coefficient of I this side? It is lambda I. Lambda L, sorry. The coefficient of I is lambda L. Okay. So we can say that x minus x1 by L is lambda. Similarly, when you equate coefficient of j with j, you are going to get y minus y1 by m. Similarly, the third one you will get z minus z1 by n. What is that? What is that we got? We got the equation of line passing through a point whose coordinates are x1, y1, z1 parallel to a line whose direction cosines are lmn in Cartesian form. In vector form, this is the equation. R equal to a plus lambda b. But in Cartesian form, what is the equation? X minus x1 by L equal to y minus y1 by m equal to z minus z1 by n equal to lambda. That is called Cartesian equation of a line. Same thing he explains here. X minus x1 by a, y minus y1 by b, z minus z1 by c. Okay. You can take denominator as direction cosines. You can also take denominator as direction ratios because they are proportionate to each other. You can write in LMN form, you can write in ABC form. Both are correct. So this derivation we have already done it. We will move to the another equation. This is the second equation. He says, find the equation of a line passing through 2 points. Remember, every time he will be giving two things. In the first one, what he gave line is passing through a point, it is parallel to a vector. But now he is not giving parallel to a vector, he says it is passing through 2 points. Just draw any line, let us say this is the line L. You can choose any points, let us say this is A and this is B. Line is passing through 2 points, okay, and we want to find the equation of this line. It is passing through 2 points, their position vectors are known. Let us say this is vector A and this is vector B. We want to find out equation of a line which is passing through 2 points whose position vectors are A and B. As we discussed earlier, whatever he gives, we always choose an arbitrary point on the line. Okay? Choose point anywhere of your wish. Now let us say I am taking a point from here, let us say this is P, and if it is so, I take it as R. The point which we choose, always we take the vector as R. Okay? So now look at this diagram. A, P, B. You find that A, P, B are collinear. What do you mean by collinear? You can express, let us say, vector AP lambda times AB. Either it is double or it is triple or it is half or it is 3/4 or 3, anything, some scalar times. So what is AP? Now you write AP is R minus A. Why? Why AP is R minus A? Why do you say AP is equal to R minus A? To find out vector AP, it is position vector of P minus position vector of A, R minus A. Similarly, lambda times, what is AB? If you have to write vector AB, how do you write? Position vector of B minus position vector of A. So you get you got the equation. What is the equation? The equation is R is equal to A plus lambda B minus A. This is called equation of a line passing through 2 points whose position vectors are A and B. Can we convert it into Cartesian form? If you take Cartesian form, what changes you have to make? You have to convert them into coordinates. How do you do? A is first point, so let us say coordinates are x1, y1, z1. P, we always take it as x, y, z. B, we take it as x2, y2, z2. Make those substitutions here in ijk form, component form. So what you will get? You will get xi plus yj plus zk equal to A, that is x1i plus y1j plus z1k. In component form we are writing plus lambda times B minus A. How do you write B minus A? B minus A, how do you write? We will write it as x2 minus x1i plus y2 minus y1j plus z2 minus z1k. This is in component form. What we need to do? Get this side. So if you get this side, you will get x minus x1i plus y minus y1j plus z minus z1k equal to lambda times this whole thing will remain as it is. This whole thing we will write here. Like previous one, equate the coefficients of ijk. What is the coefficient of I in the left side? It is x minus x1 equal to, what is the coefficient of I in the right hand side? It is lambda into x2 minus x1. As a result, we can say x minus x1 by x2 minus x1 equal to lambda. Similarly, if you equate coefficients of y from left hand side and right hand side, you will get y minus y1 equal to lambda times y2 minus y1, or lambda can be written as y minus y1 upon y2 minus y1. Similarly, z minus z1 upon z2 minus z1. This is called Cartesian equation of a straight line passing through 2 points whose coordinates are x1, y1, z1 and x2, y2, z2. So this is called vector equation, this is called Cartesian equation. He has shown here the vector equation. With that, we come to a close of this particular session. We will study about straight line further in the next session. Thank you. Sai Ram.